In radar technology, an active electronically scanned array, AESA, is a type of phased array antenna in which the beam of radio waves can be electronically steered to point in different directions without moving the antenna. In the AESA, each antenna element is connected to a small solid-state transmit-receive module (TRM) under the control of a computer, which performs the functions of a transmitter and/or receiver for the antenna. AESAs are more advanced, sophisticated, and second generation of the original PESA phased array technology. PESAs can only emit a single beam of radio waves at a single frequency at a time. The PESA must utilize a Butler matrix if multiple beams are required. The AESA can radiate multiple beams of radio waves at multiple frequencies simultaneously. AESA radars can spread their signal emissions across a wider range of frequencies, which makes them more difficult to detect over background noise, allowing ships and aircraft to radiate powerful radar signals while still remaining stealthy, as well as being more resistant to jamming. AESAs are also more efficient than PESAs, as they do not require the use of a large number of bulky and power-hungry waveguides to transmit and receive radio waves. This makes them lighter and more compact, which is important for aircraft and other mobile platforms. AESAs are becoming increasingly common in military and commercial radar applications. They are used in a wide variety of systems, including air traffic control radars, weather radars, and missile guidance systems. Here are some of the advantages of AESA radars. Increased performance. AESA radars can provide improved performance in terms of range, resolution, and accuracy. Reduced size and weight. AESA radars are smaller and lighter than traditional radars, which makes them more suitable for mobile applications. Improved reliability. AESA radars are more reliable than traditional radars, as they do not have as many moving parts. Lower cost. AESA radars are becoming more affordable, which is making them more accessible to a wider range of users. Here are some of the disadvantages of AESA radars. Complexity. AESA radars are more complex than traditional radars, which makes them more difficult to design, manufacture, and maintain. Cost. AESA radars are more expensive than traditional radars. Performance. AESA radars may not be able to provide the same level of performance as traditional radars in certain situations, such as when there is a lot of electronic interference. Active electronically scanned array, AESA, is a type of phased array radar system that is used for detecting and tracking objects, primarily in military applications. It is a more advanced and versatile technology compared to traditional mechanically scanned radar systems. In AESA, the radar antenna is composed of numerous individual transmit-receive modules, each equipped with its own small solid-state transmitter and receiver. These modules work in unison to transmit and receive radar signals, allowing for a high degree of flexibility and control over the radar beam. The main advantage of AESA over traditional radar systems is its ability to electronically steer the radar beam without the need for mechanical movement of the antenna. By manipulating the phase and amplitude of the signals transmitted and received by each individual module, AESA can electronically steer the radar beam in different directions almost instantaneously. This enables rapid scanning of the surrounding airspace and the ability to track multiple targets simultaneously. AESA radar systems offer several benefits, including improved detection range, higher resolution, enhanced target tracking capabilities, and increased resistance to jamming. They also have a faster response time and can adapt their scanning patterns dynamically, which is particularly useful for detecting and tracking agile targets such as aircraft or missiles. AESA technology is widely used in modern military aircraft, naval vessels, and ground-based radar systems. It provides enhanced situational awareness and helps in detecting and engaging threats more effectively. Additionally, AESA radars can be used for electronic warfare purposes, such as jamming or deception techniques. Overall, AESA represents a significant advancement in radar technology, providing superior performance and flexibility compared to traditional radar systems. What is an active electronically scanned array or AESA? Active electronically scanned array or AESA is a phased array system in which the beam of signals can be steered electronically in any direction without physically moving the antenna. The antenna consists of an array of small antennas, each with a separate feed. The beam is steered electronically by controlling the phase of the radio waves transmitted and received by each of the multiple radiating elements in the antenna. This digitally controlled scanning nature of the AESA allows it to quickly scan any direction in comparison to a mechanically scanned radar, whose range is constrained by the direction it is facing and how quickly its motors can turn it. AESAs are mainly used in radars providing incomparable detection, targeting, tracking, and self-protection capabilities. In AESA, every element has its own transmit-receive module, TRM, which makes this system more reliable as the failure of a single element won't hinder the functioning of the system. This is an image of an AESA from Macom. Each antenna element has a separate feed, amplifier, and heat sink. Two main applications of active electronically scanned arrays are 5G and radars. 5G uses beam steering technology that operates using AESA technology to increase throughput and deliver the high data rates required. Radars that use AESA technology do not need to be mechanically steered and have less moving parts, which increase the lifetime of the radars and lowers the maintenance costs. In addition to the physical benefits, AESA-based radars are less susceptible to electronic jamming. Traditional radars use the same frequency to broadcast the signals, which the jammers determine and transmits a signal at that same frequency to confuse the radar receiver. But the AESA radars use a technique called chirping, by which they transmit the signals over a wide band of spectrum, making it difficult for the jammers to jam an AESA system. AESA radars also have low interception, as they don't have a fixed pulse repetition frequency, which reduces the antenna radar signature and hence makes it less traceable. So they are often used to build radars on Air Force planes.